Okay, for question 4a. Now this one actually will test you on the concept of chain rule for differentiation. Now we are given two functions. We do not know what the functions are. We only know that for the function g, at x equals to 5, the function g will give the so-called y coordinate as 1. And at x equals to 5, we know that the gradient, which is g prime 5, is actually equals to minus 3. Now, given all these things, and the fact that we know that fx and gx is actually linked by this equation here, we are then supposed to find out what f prime 5 is. So we will have to go and differentiate. So doing the differentiation by chain rule, we know that we have to differentiate the tangent first. So differentiate tangent, we have secant square. Okay. Then by chain rule, I have to differentiate the egx, which we know that differentiate the exponential, we will hold it first. It's the same thing. But we have to differentiate the power, which will actually give me g prime x. So at this stage, we will then sub in the 5 to actually find what the things that we need. Okay, here have to be a bit careful. This is actually a bracket. So secant square holding eg5. I have to sub in first. Okay, and this is eg5, and this is g prime 5. So the answer is actually secant square. eg5 is g5 is 1, e1. Okay, then this one is e1. Okay, then this one is minus 3. So we will do the calculation using our GC. Okay, secant square e. Secant square e is just 1. Okay, so secant square e is just 1 over cosine square e. So what I actually do is I calculate cosine e first. Okay, I square it, I reciprocate it. Okay, then I have to multiply the number by e, and then multiply the number by minus 3. So the answer will be actually minus 9.81. So do be careful why just now I have to purposely put in the square bracket is because if I didn't put it in by the writing, some of the students may mistaken that I have to do the multiplication for the 3 round bracket first, then I take the secant square, which will actually lead to the wrong answer. Okay, so for part B, find by differentiation the range of values of x for which the function y, okay, y equals to x squared over 2x minus 1 increases as it increases, which basically means that I have to find out when y is an increasing, or when is y increasing, so called. Okay, which basically means that, when is dy dx positive. Okay, so this is actually questions that makes differentiation and equation inequalities together. So what do I need to do? Well, I have to actually do the differentiation. So square the denominator, hold the denominator, differentiate the numerator. I'm using quotient rule. Minus, hold the numerator, differentiate the denominator. So doing a bit of simplifications. 4x squared minus 2x squared over 2x minus 1 squared. So okay, I will have, okay, this one you have to be a bit careful. I will actually have 2x squared minus 2x over 2x minus 1 squared. Okay, and I actually need to have dy dx to be more than 0, which actually means that the function is increasing. This will imply that 2x minus x over 2x minus 1 square is actually positive. And this will imply that 2x squared minus 2x is positive. Why I actually can multiply the denominator over is because it's always positive, but we have to take note that x must not be equals to half. Okay, so this will implies that 2x bracket x minus 1 is more than 0. So by doing a number test, we know that the critical point is 0, 1, and if you do the number test, and we know that it must not be equals to half. Okay, by doing the number test region, we will have this as positive, this whole region as negative, this is positive, and therefore the answer is x less than 0, x more than 1.